Spotlight. Good morning everyone. My name is Jörn Schmidt, I'm a German SciComm member, and it's my pleasure to welcome you this morning after this beautiful reception last night. I'm really happy that so many of you came actually half an hour earlier today to join us for the keynote speaker, and it's also my pleasure and honor to introduce to you Eva Plagányi. Eva studied applied mathematics, botany and zoology in South Africa and did a master in marine ecology and actually got 2 awards for that. And she worked for a couple of years at the University of Cape Town before she moved to Australia to join CSIRO. And her main focus are marine or are biological models coupled to or in the use of marine and other renewable biological resources. In the context of Australia, I wonder what these are, but she's working strongly interdisciplinary in the field of cross-cutting applied mathematics with ecology, and has worked a lot on different kinds of ecosystem models, stock assessment models, marine strategy evaluation, and also socio-ecological models. And I could have introduced her as now something about mice and fish. Eva.
Good morning, ladies and gentlemen. It's a real honor to be invited to come to your meeting and share with you a little bit of perspectives and work that we're doing in the Southern Hemisphere, together with a large number of my colleagues at CSIRO. So to start with, I wanted to ask the question about whether ecosystem approaches are driving a paradigm shift in fisheries science. And I thought it would be appropriate to start with trying to conduct a bit of a fisheries toolbox timeline. It's a little bit biased from my perspective, starting with a logistic equation in 1838. And then undoubtedly there have been a few key turning points along the way. The advent of computers changed a lot of the way that we do our science. And then there were some key agreements around some key concepts that underpin a lot of the fundamentals of the way we do our fisheries science. For example, the concept of MSY and MEY. Moving on from there, the next big turning point was the huge sort of move towards ecosystem approaches to fisheries and the development of a large range of different ecosystem models, as well as decision support tools such as management strategy evaluation. And there are too many sort of great legends, some of them in the audience here, that have contributed to the development of these, to list all of those. So what was next from there? I'd suggest that was around about the same time, but increasingly the ecosystem modeling and approach to fisheries brought together a lot of interdisciplinary scientists, which was fortuitous because about the same time we started recognizing the need to link our science with some of the climate forcing that was happening. So where are we now? Well, I'd suggest we're currently in the marine social revolution. So we're increasingly needing to upload humans into our models. These are sort of integrated socio-ecological models, concepts such as the triple bottom line. So moving from MSY to MEY to triple bottom line that also includes social considerations. What's next? Well, possibly it's increasing tools to deal with all marine users. So seeing as this is an ICES meeting, I have been trying to figure out where ICES fits on the timeline, or in fact, whether ICES has written the timeline, given a number of key meetings in the last few years around these topics. So how do we arm ourselves with the tools for social revolution, tools that can expand the way we do fisheries and deal with some of the modern challenges? So in order to address this, I'm going to draw on a few different examples, and starting with the motivation for why I'm arguing we are in the middle of the social revolution and increasingly need to account for ecosystem approaches. I'll be giving an example of triple bottom line approaches, and then moving on to some comparisons between food webs and supply chains, which I'll be explaining in a short while, as well as increasing roles for ecosystem models, and I'll be sharing with you my pet project, which are the mice. I like mice because they're small, fast, and smart. I'll then be explaining how we're trying to couple mice with what I'm talking about as a sense of place, and hopefully in this way give you some examples of practical ways we can expand our fisheries sort of toolbox to deal with some of the modern problems we're facing. So I think most people recognize that the modern Anthropocene ocean is an extremely complicated place. It's no longer possible to consider a single fishery in isolation of all the complex drivers. So for example, the fate of a fish in some remote corner of the ocean can often be determined by an exchange rate fluctuation in some other part of the globe. There's increasing globalization that affects the way that the whole system works. It's an incredibly complex, connected, interlinked system, and we need to start trying to understand some of these dependencies if we want to do a good job of managing the oceans. On top of these complex connections, we also have climate change further challenging the way we think about science and some of the forcing change in the oceans. So how do we deal with this complexity? Well, I think in many ways, the key to ocean rescue might be a better sort of sense of place, sort of understanding our role as humans in that system is fundamental to improving the way we're able to manage the oceans. So for the early career scientists, I'm going to begin where I began, which was working on South African abalone. And for several years, I thought I was doing a really good job, doing a really rigorous stock assessment of this resource. But really what I was doing was accurately documenting the decline of the resource. And it didn't matter how good my stock assessment models were, I wasn't actually able to make a real difference in terms of what was happening to the fishery, these downward trends, because of two other very important things happening. And the first one was the socio-political backdrop. By not considering the socio-political drivers that were leading to increased levels of poaching, the fundamental declines in the resource couldn't be reversed, because these were driven by a complexity of factors which needed to be addressed at their root in order to change the situation. So just for interest, you can see a short history here of the abalone catches, and over time, over the last few decades, decreases in the commercial and recreational catches, in fact the recreational fishery was closed, with increasing illegal catches, which the model estimated for some years was 10 times the legal catch. And we validated those figures by comparing with trade information as well. So the first lesson I learned from working on this fishery was that one needs to consider the socio-political setting of a fishery. As if that wasn't challenging enough for the resource, there were also complex ecosystem interactions in this fishery. And very briefly, what happened here is that there was some sort of environmental change which led to rock lobsters invading the range of the abalone. The rock lobsters ate all the urchins, and the juvenile abalone needed to shelter under the urchins. So with the urchins gone, the mortality of the abalone increased substantially, and this further caused declines in the resource. So again, we needed to understand some of these complex ecosystem interactions in order to understand what was happening with this resource. And this is where simple ecosystem models can be really helpful in trying to integrate and help our understanding of what's happening, both in terms of currently as well as future projections. They also have an important role in a climate change context in terms of being used as simulation tools to basically try to look for climate-smart strategies. So as one example here, we use this multi-species model to first of all simulate the current overfishing scenarios. So lobsters invaded the range of abalone, depleted the urchins, changed the benthos, and crashed the abalone population. But what if we could rewrite history and, for example, look at what happened if the fish population wasn't overfished, if there had been a sustainable fishery? Well, what our model suggested in that case is that the fish would have kept the lobsters in check as they started invading the area, and in fact, you wouldn't have got this regime shift. So these sort of models can also help us look for factors that help keep these systems resilient to change. So importantly, I've talked about the importance of considering both the sort of ecological and governance aspects that are linked into particular fisheries. And just to further underline my point, I thought I'd draw your attention to a recent paper on bright spots amongst the world's coral reefs by Josh Sinner and colleagues. And I really like this paper because they looked around the world at where were there areas where basically the reefs or the ecosystem was doing better than you would expect, given the current sort of population and other drivers in the system. And they identified a number of factors that explained that. And those included both strong socio-cultural institutions, things like having good tenure and engagement and dependence of communities on the neighbouring resources, as well as favourable environmental factors such as deep water refuges. So underlining again the need to look at both social and ecological aspects. So just to summarise so far, I've talked about the fact that ecological, sociocultural and economic factors are all important in sustainable management of the ocean, and climate change is an additional driver. So how can we deal with some of this complexity? And I hope to share with you some sort of what I think of as more practical tools that we can use in our fishery toolbox to deal with these challenges. And to do that, I'm going to draw on one of my study areas, which is Torres Straits. And as you may not know where the Torres Straits are, well, they're a very long way from Riga. And basically, they're this area of stretch of water between the northeastern tip of Australia and Papua New Guinea. And the fishery is a shared fishery between Australia and Papua New Guinea. And within Australia, it's economically the most important fishery in the region. And it's predominantly utilised by Torres Strait traditional owners. There's also a non-traditional sector of the fishery. So we have these three sectors: Papua New Guinea, traditional Torres Strait Islanders, as well as a non-traditional Australian sector, all utilising this fishery with different drivers for fishing, different objectives in terms of what they'd like from the fishery. But importantly in this fishery, the Torres Strait Treaty actually explicitly recognises the need to maintain the traditional way of life and livelihood of the Torres Strait Islanders. So there's an explicit social objective that recognises that the fishery is not only economically important in the region, but it's also important to the lifestyle and livelihood of the indigenous people of the Torres Straits. So in terms of how we, again, bring this sort of complexity into our management tools, well, what we did in this project was really to build on some of the standard approaches that we use in fisheries assessment. So at the core, we'd have a fisheries ecological stock assessment model. But around that then, we worked with an interdisciplinary team of researchers and linked together a number of different models. So apart from the biological model, we had linked economic models, and then we also had linked social analyses. Some of these were purely qualitative, and we didn't want to lose that important information. And where possible, as I'll explain in a minute, we tried to sort of quantify some of the social information. And we then used this framework to compare the performance of alternative management strategies, and we evaluated the performance in terms of performance indicators, which included not only the more traditional biological and economic performance indicators, but also socio-cultural indicators. And because some of the information was qualitative and we wanted to give it the same weight as the quantitative, people in these different groups change, and that in turn feeds into the biological model in terms of changing who's going to fish, how many people are going to fish, and because it was a spatial model, where is that fishing going to happen? As I mentioned, a very important component of this is to have very extensive stakeholder engagement and involvement. And we then put together the different performance indicators, and I'm only showing you here some of the social indicators. And so for various alternatives, we could map out green being a positive impact, red being negative, and blue being neutral. How did a particular scenario perform, and then compare the performance of these. So what this does is it it doesn't show you there's one clear answer. The idea of this isn't to get what is the correct or optimal answer. The idea is to make explicit the various trade-offs for everybody to see. It's very transparent, and if you're going to choose one scenario, you have to be aware that there's some positives and some negatives, and this framework makes explicit what those are. So it really is a good basis for informing our decision-making. Importantly, some of the two of the key social indicators that emerged are pretty much universal indicators in many cases, and these were that ownership and equity were the foremost social drivers for the traditional sector. And so trying to work towards figuring out which are these key social indicators, I think also helps us deal with the myriad of complexity out there in terms of, the different social indicators that we need to think about in any particular system. So just to summarize some of the key points from that study, firstly, we showed there was a complexity of trade-offs between social and economic considerations. So as I mentioned, there's no single answer, but an approach like this can make explicit what those trade-offs are. So if you're going for the option that maximizes the profits for a particular sector, you need to be aware that there might be some negatives in terms of, some lifestyle preferences, social indicators, community coherence was a problem with some of the strategies we tried, and so forth. So at least you can proactively prepare for how to deal with those if you are going to choose a particular strategy or you have some insight beforehand. And really the idea of this approach was, as I mentioned, to make explicit the triple bottom line approach, so a sort of objective way to give equal weight to social, biological, and economic indicators. But the story doesn't really stop. If we're really worried about this fishery, we can't actually stop at the point at which a fisherman, these are all fishermen in this system, lands the lobster or lands the fish. We have to actually worry about the journey of that fish all the way from the point at which it's landed until it ends up on the plate of a consumer somewhere. If you eat it on the beach, you're done, it's simple. But in most cases, as I mentioned, with increasing globalization and this connected world, that's not the case. And so is there any, why do we need to consider the supply chain? Well, the livelihood of that fisher depends in many cases not only on whether or not you've caught enough fish in the ocean, but also on that fish being successfully moved all along the supply chain to where you want it to go. So just to briefly, for those of you like me a few years ago, asked the question, what is a supply chain? I had no idea. There was a whole research field on supply chains out there. It's basically the people, businesses, and organizations involved in getting fish from those that catch it to the consumer. So it's that whole chain of events along there. And many fisheries have quite complicated and long supply chains. So there's a lot that can go wrong along those supply chains. And so if we can focus some of our work on looking at how can we increase the resilience of those supply chains, that can certainly increase the resilience of the whole system. So in many ways, these supply chains actually look quite similar to food webs and social networks. And so, again, I wanted to use this as an example of how we can sort of integrate the methods we used in ecology and the methods that are used in the social sciences. There's been a huge bridge between those, and we're starting to talk to each other, we're starting to look at each other's approaches and find common ground, but we can also swap tools and methods and thinking between the different areas. So supply chain analyses have typically been all qualitative, and so what we were interested in was thinking of, can we use some of the quantitative tools we use for food webs to help us understand these supply chains? And firstly, what tools do we use in the food webs? Well, just as one example, this is an index called SURF that I developed with Tim Essington. And this was basically to identify key species in marine food webs. So species like forage fish are key links in a food web. If you remove that particular element from a food web, the whole system could fall down because they're really key in moving your energy and your production all the way from the phytoplankton through to the top predators in the system and ultimately to humans on the other side as well. So we have a flow through a food web, and we have methods that can identify, in this case based on diet fractions, whether or not a species is key in that system. And so we know we need to do certain things to maintain the sort of integrity of that system. In the same way, we can think about key elements in a supply chain. So we can represent a supply chain as having elements with links between them as well, and look at which are the elements in that chain that are critical, and can we identify them using a sort of similar method. And the method that my colleagues and myself, in a project led by Alistair Hobday, who's in the audience at the moment, we developed a supply chain index, which was a relatively simple way to try to identify these key elements based on the sort of connectivity of different elements, as well as the sort of throughput through different elements. So for example, if you think about a simple linear chain, if you break one of these links here, the whole chain breaks, right? So this is not a very resilient chain. It has a supply chain index of 1. And as you reduce your supply chain index with more connections, you increase the resilience. But that happens not particularly in a linear way with this index. And we've done a little bit of work that has validated that this index does seem to work. So this is a simple quantitative method that we can use to identify these critical vulnerabilities and then look at ways to increase the resilience to disruptions, including climate change shocks, for example. So that could be, if there's flooding, it can disrupt your transport pathway. Do you have an alternative transport pathway, for example? And we did this for a number of different fisheries. This is an example for a banana prawn in our northern prawn fishery in Australia. And here I've highlighted the key elements, which were, in this case, the supermarkets and the domestic consumers, which was quite different to some other fisheries, like the Torres Strait lobster. The key element there was the Chinese consumers at the other end. So this gives us some insights into differences in the structure of these different supply chains. We've also extended that analysis more recently to say, well, can we apply this to other industries and sectors as well? And so we put together with some colleagues at CSIRO some examples from aquaculture, from mining, from agriculture using rice. Mining, we were looking for the weak links in the diamond chain. And we analyzed all of them in the same way. So we used this consistent sort of framework to analyze these different supply chains, come up with standardized indices, and then make some conclusions about the resilience of them. So in this case, this work is currently in prep. We're hoping to submit it shortly. But we basically forced some perturbations on the systems, and we looked at how resilient the different complex and simple supply chains were. And just as an example, we're starting to find that certainly some of the more complex supply chains are actually much more resilient to these perturbations, which is an interesting result because a lot of the supply chain literature is focused on how to simplify supply chains for economic reasons. But when you start thinking about impacts like climate change as well, perhaps you need to think about adding more connections in these chains as well. So just a summary on the supply chains. Basically, this work, as I mentioned, was aimed at addressing the vulnerable elements in supply chains, and then we focused on working with industry and thinking up what could be some adaptation options to strengthen particularly some of those key vulnerable areas in the supply chains. And as I mentioned, increasing resilience to climate change, our work is suggesting that this might involve diversifying the networks. Okay, so where are we? I'm sort of taking you on a bit of a roundabout tour of how we deal with complexity. So far we've talked about, on the human end of things, concepts like ownership and equity and triple bottom line and how they're important drivers for what happens in fisheries and some of the tools we can use to deal with those, as well as how we can identify both key species in ecosystems as well as key elements which help direct our focus of where should we concentrate a lot of our focus. So I'm going to move now back to the other end, the connections that are linked to fish, and just think briefly about what kind of modelling approaches we can use. And most of you have heard me talk ad nauseum about mice, but I'm going to briefly introduce again what I mean by the concept of mice. So mice are models of intermediate complexity for ecosystem assessments. And really what we've done in this plot is we took a number of the sort of approaches we use in Australia and we plotted them on 3 different axes of increasing physical complexity, biological complexity, and human complexity, and looking at roughly how much complexity is included in each of these components. And ideally what one wants as a fishery manager is you want a sort of toolbox that covers a lot of these different spectrums, because obviously different tools are used for different purposes. So mice are intermediate in complexity. They're towards the tactical end, so they're designed to be approaches that you can actually use in sort of practical fisheries management. Whereas up at the top are the big cats, the complex assessment tools, like Atlantis, for example. As you know, cats are good at strategic thinking, and that's really where these models are used, is for some of the bigger scale, strategic, broad picture setting type work. And down at the bottom are the rats that stay low and avoid the top predators. So rats have a role too. But for now, I'm going to restrict my focus to models of intermediate complexity. And really, these models are at the sweet spot on the variance complexity trade-off. So some of the mice examples, a growing number of mice around the world. So in Australia, we're developing a number of different examples. A recent work has focused a lot on the crown of thorns starfish interacting with coral on the Great Barrier Reef. We've also focused on the Antarctic systems. There are a number of examples around the world, and then we're using a simpler kind of mice as part of a Belmont Forum Gulls project as well, where we have some examples from around the world. So in a nutshell, these mice, as I mentioned, are intermediate complexity. They focus on a subset of the ecosystem. The equations we use for them, well, there's no sort of one equation or no black box. It's really tailored depending on what you include in the model and what's important. So if you have a lot of information on a species, you might do a size-structured model to represent your lobster population. But, for example, the coral in some of our mice models, we don't have detailed information on it, so we use a simple Schaefer surplus production model for that, or we use age-structured equations for some. So we tailor it depending on how much information there is. And importantly, we try to fit the model to all available information. So we try to ground truth this model, which you can't really do with those bigger ecosystem models because we simply don't have the data on all of the components. You still need the bigger models for certain questions you might want to ask, but the mice are aimed at addressing specific sort of targeted management questions where you just focus on your key species and your key interactions or key components. And they can also have linked physical and human dimensions. So how do we make mice more social? Well, as I mentioned, these mice models can have linked ecological, environmental, and human components. And what this schematic shows is that there's a lot of complexity in each of these components. But what a mice model would do is say, right, this is my management question, and these in the shaded area says these are the components that I'm going to focus my model on. The human component, there's some standard things we can do with human components, fleet dynamics models, and so forth. But what I'd like to talk about is how we can include some more sort of in-depth thinking around the human components in these mice models. And to do that, I started off thinking about, well, what actually drives changes in participation in fishing? So if we just think about that question, so how the human population interacts with the fish population, well, if you're going to catch the fish or leave the fish, it really depends on the participation in that activity. And there are a number of things that increase or decrease participation. So for example, economic drivers, like the example of the abalone population I showed you, and similarly sea cucumbers, highly valuable resources like that, they're very strong economic drivers that push for a lot of overfishing. They push for a lot of participation in fishing. So we need to understand what those drivers are. We talked a little bit about the role of governance. So good governance can actually help control that fishing effort. Poor governance will drive increases in fishing effort. Resource status will obviously drive how many people participate. If there's lots of fish, everybody wants to go and catch one. Capacity and infrastructure drive the ability of how much we can actually participate, how many fish we can take out, as well as the climate, which impacts not only how many fish are there and what their growth rates are and so forth, but also the ability to actually go out and do the fishing or have the infrastructure that you need. But what about this missing dimension? There is another dimension to this that most people understand, but it's a very hard one to get our heads around, and that's really around, how do we quantify the quality of an ecosystem as assessed by users? So when we look at a system, do we think that's somewhere I'd like to go on holiday, or does a recreational fisher think that's somewhere I want to go and catch fish, or does a commercial fisherman look at a system and think, I think I could catch a lot of a particularly valuable species in that system? And that certainly is another one of these important drivers for what changes participation in fishing. And here I'm going to argue that we can sort of represent this as a sense of place. So what is sense of place? So I called this something else initially, and social scientists that I work with said to me, I think what you're talking about is actually sense of place. And reading up about it, it is pretty much what I was thinking about. It's the emotions associated with a place. It's created by the physical and social features that make up the environment. So sense of place is affected negatively or positively by environmental change. So if you have a favorite holiday place you go to and it's beautiful beach and there's lovely clear water, then as a tourist you're going to go back there. But if there's an oil spill and suddenly there's oil on the beach, or there's a whole lot of rubbish, or there's nothing for you to see, that's going to influence whether or not you participate as a tourist in that activity. So there's this feedback between the natural system. If it's an absolutely amazing place with lots of fish, it's going to draw a lot more fishers to the area, and that will ultimately feed back in there being less fish, and so that comes back to there's now fewer people. Does that mean the fish start increasing again? So there are these feedbacks between the social system and the ecological system. And what we can do is we can put ourselves in those models. So the same age-structured equations I use for fish, I can use them for humans, and I can model how do the populations of different user groups change, the population of the tourists, the commercial fishers, and so forth. And that way I can start dynamically simulating these feedbacks between the natural and the social system. So this particular index that my colleagues, particularly with Ingrid van Putten and I, have developed is called the SOPI index, the Sense of Place Index, which is really intended, as I said, just to capture this feedback between the two systems. And so we started thinking about, can we use something like this in a socio-ecological model to help us integrate some of these complex sort of socio-psychological dimensions into our more quantitative tools that we use for management? So as an example, the actual complexity, it's pretty complex. So if we think about our environmental variables and the links with the resource users, well, environmental variables, things like the fish abundance, your habitat, the presence of rubbish, your water quality, and so forth. And the different resource users will ascribe different importance to these different environmental variables that will inform whether or not they want to participate in an activity. So if we just consider a slightly simplified version of that system with 3 environmental variables as a start and 3 different resource user groups. So these would be the tourists, which are really transients to the systems, and then we have resident populations, which are either observers or extractive users. And what we've tried to do in our sort of prototype model is to link these two with our sense of place index, and that sense of place index is going to drive changes in participation by these different groups, so migration into an area or out of an area. So as an example, we can construct sense of place index response curves for the different users. And so, for example, our 3 user groups are indicated by the 3 different curves. And if you think of an environmental variable like water quality, the different groups, as your water quality improves or increases over time, the sense of place index is going to be different for the different users. And as a start to this, one can sort of draw these curves just based on common sense, right? That would be a starting point. In many cases, there is good social information that can help inform how we draw these. But really what we're interested in is also trying to take this further to try to see whether we can empirically sort of validate some of these. And there certainly are examples of cases where a certain change has occurred, there's some development or some change, and there are records of how participation by different user groups has changed over time. So I think we could actually empirically validate these curves. So if we do that, we can then use it in our model. And again, using this simple prototype example, here we looked at how will the system respond to a perturbation again. So we've got some different scenarios around development, tourism, etc. And what you can do with this model is you can then try out for the different scenarios what will be the changes in the environmental variables as well as in the participation. So just as a simple example, say you have a development in an area, it'll increase your jobs and migration to the area. Depending on the development, this might decrease your water quality. That will negatively affect your fish. That'll feed back to negatively affecting your tourist groups, and you'll end up with fewer users in the area, and so perhaps there'll be another stabilization of the fish. And to illustrate this, we've done some simple simulations with this SOAPy feedback and no SOAPy feedback. So if we run a model ignoring that there are actually dynamic feedbacks between the social and ecological system, we get quite different results to if we build that feedback in. So on the left here, you can see we get changes in some of the different groups compared to on the right. And similarly, we get things like without the SOAPy feedback, we underpredict the resident numbers, for example. And so this is just an example of if you're providing advice for some sort of planning or development scenario, if you don't include these links in your understanding and your projections, you're not going to make accurate predictions. Here again, you're going to overpredict the tourist numbers by ignoring this link. And similarly for our environmental variables, if we have with feedback and without feedback, a simple example here would be the predictions for the fish population. Without feedback, under particular, this was the building a fish factory scenario, we had a decline in fish populations in the region, but with the SOAPy feedback, with these complex considerations of how participation by the different user groups will change over time, we get different predictions. So just some key points around that SOAPy index. Really what we tried to challenge ourselves with there was to incorporate some of the psychological characteristics, and we do that using the sense of place concept as a starting point, and we'd argue it can have important long-term implications for the predictions we make about systems. We also think that this could be directly applicable to planning, policy making, and decision making. So our starting example, we started with a slightly constrained example, which is focused on Maria Island in Tasmania, where we have sort of tourism, we have a marine protected area, and we have a lot of commercial fisheries, for example. So we're busy coupling the approach. This was just a very simple initial model. We're coupling it to a more complicated mice model with a lot of complexity, and then using it to see under various scenarios how participation by tourists, by commercial divers, by recreational fishers changes over time. So just stepping back again from some of the complexity, really what we're trying to do in fisheries management is quite simple. We're trying to manage this interaction between fish and humans so as to avoid B, biological overexploitation and economic overexploitation, to achieve C, future sustainability. And we started out early stages of that timeline I showed you, doing this in fairly simple ways that focused very narrowly on this particular part of that. But we're increasingly recognizing that the picture is much more complicated. It's more complicated the human side. We know that humans don't sort of interact here in isolation of all these other complex factors. They're part of a connected web, social networks, their connections along the supply chain, their sense of place that influences their decisions. Going the other side, a fish as well is part of a complex network. Sometimes we need to understand that complexity in order to think about how best to manage the system. And on top of that, we have climate forcing, driving changes in all aspects of the system. Plus, we have this additional layer of all the sort of multiple use conflicts and other ocean uses. So we need to be thinking about all of these components if we want to do a good job managing fisheries. We can't just focus on a single one. I mean, obviously, we need in-depth looks at all of those. But what I've tried to do this morning is just show you some examples of some sort of relatively simple, practical ways we can start trying to integrate and pull these things together to help provide a basis for our decision making. So just to conclude, really the main point I wanted to make is that we're no longer simply observers and users of natural systems, but we're integrated components of these systems. We're basically in the systems that we're modeling ourselves, and we need to be thinking about what our role is. And the reason we need to think about that is because it's one of the important levers that will change and cause changes in fisheries, and it's a management lever that we can use to achieve some of the things we're trying to achieve in our ocean fishery management and conservation. So effective management, hopefully I've shown you, it can mean relying on more levers than just adjusting, the total allowable catch for a fishery, for example. Other levers go all the way through to governance, socio-political considerations, supply chain analyses. Supply chains can help us achieve some of the things we want to achieve with fisheries. If we strengthen those, or if we value add in those, we might be able to reduce the total catch, for example, of a particular species. So these are all interlinked components that will influence how well we do in managing these complex systems. And lastly, hopefully a little bit different perspective on some of the ways down in the southern hemisphere that we extending the toolbox of ecosystem approaches in practical and tractable ways to try to help us with the social revolution that I'm arguing is underway. So finally, just like to thank a large number of my colleagues. I work with very large sort of interdisciplinary groups at CSIRO. I'm very fortunate to work with some very smart people who've helped inform my own thinking about the need to broaden our research focus. And thank you also to the ICES organizers for inviting me here. So thank you.
Yeah, thank you very much for the wonderful talk. And you said that you love to get some questions, and you left enough time for that. So we open the floor for questions for Eva. And the runner this morning is a real runner, so I try to support you. Natalie.
Well done. My name is Natalie Steins. I'm a social scientist. I was very inspired by your talk, and you started with this position saying, well, we're in a marine social revolution at this moment. And I would really like to think that, but I think within the ICES community, we are just sort of starting to work on this social dimension. And ICES has obviously always very much focused on the natural scientist and science and fisheries management, and is now looking for ways of how to include the human dimension as well. And there is a strategic initiative, and I think you earn a badge, Jörn. But that was not my question. My question is if you have any, you obviously have a lot of experience with integrating these sciences and making social and natural scientists work together in your projects. So do you have any recommendations for ICES on how we could do, well, sort of go on a similar route? I mean, what are the pitfalls and what are the do's and don'ts?
Do I have to start with such a hard question? Yeah, it's a good question, and I appreciate that, you know, not everybody's joining the social revolution at the same time. And part of what I wanted to achieve this morning was to try to, I started out as quite a skeptic. I'm a sort of little bit of a hardcore quantitative scientist myself, but I've always recognized, you know, that people are important too. But I started out thinking, well, it's just too hard. You know, how do we include people? We can't do it. And gradually, you know, I've sort of been convinced that there are some practical ways we can make. And so I guess from my perspective, it's around, well, let's start somewhere, and let's start somewhere that is sort of like my MICE philosophy. It's let's focus on some key components, some key drivers, some key things we can do, because although, as I mentioned, there is a role for trying to look at all the complexity and, you know, using models like that. My own particular focus, particularly from a management perspective, is to try to do things that we can ground truth and try to sort of start simple and gradually build out from there. And that's pretty much what we've done in some of our approaches in Australia. We've sort of taken, rather than, you know, throwing out some of the tried and tested tools, like single species stock assessments have a really important role, but we've just stepped back a little bit and taken small steps to broaden those. So we've added on a supply chain, for example, and said, hold on, if I do some things, think about some things along the supply chain, I can actually make some changes to how the fishery is managed, or bolt on, you know, triple bottom line considerations, for example, in the same sort of framework. So I guess if I had to make a recommendation from my perspective, it would be to look for that, to start off with just narrowing, reducing that complexity down to what are some key drivers, some key components, and are there ways we can sort of build on what we're doing?
Yeah, I'm Dorothea Dunkel from the University of Bergen. Thanks, Eva, for your presentation. Can I just follow up on Natalie's point here, because we can go a little bit deeper and talk about institutional responsibility and capacity, because I think that's also an element. I think in Europe there's a lot of interesting projects, EU projects, for example, that are starting to get this more human component in social science and even humanities work, but then there's a lack in the national institutions, the national institutes that are sending scientists to ICES to do quote-unquote ICES work. So I was just wondering if you can reflect on, for example, CSIRO and the incorporation of social scientists there. Is that really important for this work, or could this work be done just through projects and collaborating with other institutions around the world?
Yeah, it's a good question, and you know, Alistair might want to comment on this too, because I think there are a few reasons why in Australia we've gone quite far down this path, because it has been enabled by the fact that we work in an organisation that is very interdisciplinary. So, for example, when I arrived in Australia 8 years ago, and I was tasked with doing the stock assessment of the Torres Strait rock lobster resource, and knowing what had happened in South Africa, I immediately said, well, I'll do that, but we need to think about what's important to the traditional owners as well. We need to think about other things. And I could ring up a number of colleagues and say, right, I need your social science expertise, I need your economic expertise, can we work on this project? So you do need to have, you know, the structures there, and we have a few teams that have worked very well together now over a long period. Alistair and myself work in a few international teams where we've also established these multidisciplinary teams, and it is quite hard work, but we found that once you start building that mutual understanding, it certainly facilitates what you can do. So that's absolutely key. And I guess the other thing that's a key to the success, certainly in Australia, I heard a little bit of perspectives on this yesterday, and I'm interested to hear more about how it works in the ICES world. But I would argue in Australia we work very closely with industry. And I have been in places of the world where the fishers are sort of seen as the bad guys, and the scientists are seen as, I'm going to save the fish, and you know, you're going to destroy them. And I did hear yesterday people saying it's not really the case. You know, fishers themselves have a huge incentive to protect those stocks, and so you know, you want to work closely with them. And in Australia, we have tried to share our scientific tools with them. So Alistair presented examples of some of the sort of seasonal dynamic forecasting that is tools that they can use. And similarly, we try to share with them information that can help them with their fishing activities. They, in turn, then start building this trust relationship where they'll share with us economic information, which we can then use in turn to help them with how they manage their fishery and so forth. So I think that's another really key component, is having the very strong links between, well, I'm talking about fishermen, but between all your stakeholders, really, and having that good communication with your science and how it can benefit them, and in turn understanding how that feedbacks to your science.
Yes, these models are very complex. How do you check that these models are actually doing what you think they do? What do you do to verify them?
Right, so I'll start with, it's a very good question because it's really important in terms of, as we broaden out, because we've started with fisheries models which, you know, are quite rigorous, and there's a large community of us who focus very keenly on getting the exact parameter right for some small component of the system and validating that. And now we're sort of talking about opening it all up and having a lot looser system. So we can't do it with the same amount of rigor. But certainly thinking about the biological components, for example, that's why I personally, my preferred approach are these mice models where we actually fit them to data, and we do it in the same way we do stock assessment models. So we use likelihood functions, and we test the models, and we do sensitivity analysis to alternatives. Where we don't have a lot of information, so for example, work that we've done on those models to link it with climate forcing, we've done the same thing a number of other groups have done around the world, where we've tried to bound the uncertainties. So we'll look at the range of, you know, plausible impacts of temperature on sea cucumbers, for example. That's some of the work I've done. And then our simulations will integrate across the full range of uncertainty. And that way we don't get one answer, but we sort of get a range of potential outcomes. And usually we find that that range of outcomes, even with uncertainty, differs when you're comparing one strategy to another strategy. So it's still helpful in that respect. So you're acknowledging your uncertainty as part of it. Moving into the social dimension, so, you know, I declare quite openly I'm not a social scientist. I'm really interested in it, and I work closely with some really good people. Ingrid van Putten has led a lot of the social aspects of the work we've done, and some of that is harder to validate. So the Torres Strait work, for example, the way we did that was we validated by going back to stakeholders and saying, from the information we gathered from you, here's what we understand, you know, are important drivers. Is this right? Is anything missing? What do you think? So there's that element of communication can help. But things like the SOPI, we're only just starting on that. We're quite keen to see whether we can actually empirically validate that. I think we can. I definitely think, again, by starting with smaller, tractable examples. So you're right, it's important to think about that. And there's no simple answer to that.
So I'm interested in your supply chain analysis, and I'm used to thinking in terms of value chains and when you add the economic component to it. Most of the ones that I've seen show that the original fisher or fish farmer ends up being kind of the low man on the totem pole in terms of the amount of value that they get, even though they're the ones that take on the most risk. And I'm wondering if you're working on that aspect through your supply chain analysis, and I'm also wondering if you if you could just go a little bit more deeply into how that analysis can affect the fishery management through value-added products, or, you know, you went over that rather quickly.
Yes, thank you. It's a pretty complex field. As I said, I'm pretty new to it, and we've sort of starting on a lot of our thinking around some of that. The value added was something that we had several economists in the team that I was working with, Sean Pascoe, Olivia Tebow, who were sort of helping with how we could think about that and how we could. So the way we did the initial simple ones was just in terms of the flow of product. So where does product flow, what proportions flow through which nodes? But we also made a start at looking at the value added, and we used the value added in that Torres Strait analysis as one of the sort of variables that you could compare what was the value added for different strategies. So it was one of the indicators that we brought into that analysis. But you're quite right, that, you know, there's a whole lot more there, and we're only just starting to scratch the surface about how we do that. For me, personally, starting to think about it has been important, and some of the recent work we've been working in communities have been a workshop in Tanzania and Madagascar, for example, and looking at really complicated problems on, you know, what can you do about some of the fishing, and certainly having that as another tool, being able to say, well, actually, maybe you can fish a bit less, but we can look at focusing on, you know, the value added and how you can add more value along the supply chain, is a very valuable tool in those sort of systems where you've got very little flexibility to say, no, you can't fish. But you can say, well, if we get a bit less, we can make sure you get the same value by doing X or Y. So I would argue in that respect, it's another valuable tool. But I'd really encourage, you know, more work in this area. I know there are a few people that have been working in it. And a lot of our work in Australia has been about sort of the climate vulnerabilities and how we identify those. But there's a lot more that could be done.
Hi, I'm Trish Clay from the U.S. National Marine Fisheries Service, and I'm an anthropologist. I'm really interested in exploring more your sense of place index, but my question refers to something you talked about near the very beginning, which was the use of qualitative data. I gathered in sort of initially creating the indicators and the drivers, and I would like to hear a little bit more about your use of qualitative data.
Right, thank you. So as I mentioned, again, the Torres Strait example that we worked on, so what we did there, so Ingrid van Putten led a number of the surveys, we did semi-structured interviews and consultations with a large number of stakeholders, and over a number of years we've sort of built up quite a good trust relationship with stakeholders in that fishery. We have communication workshops annually and spend a lot of time talking to people on the ground. We then gather together the information, and as I said, a lot of that was qualitative. So I was quite keen on trying to see, you know, could we quantify some of this? Could we link it into the models that I'm familiar working with? But it became clear that there were some things that, you know, we couldn't quantify. For example, people talked about the need for equity and the need for ownership and so forth. And so what we ended up doing was simply capturing those, and we then, in these interviews, we sort of asked questions that would say, you know, if the system changed in a particular way, you know, how would you feel about it? And then we captured, for example, how people felt it might influence community coherence was one of the things they talked a lot about. And so we then sort of didn't link that directly into our modelling framework. We just retained it in parallel, and at the bottom, when we had the performance indicators, we had those all explicitly down to compare with some of the other indicators. So that's the way we used it in that project, which was sort of an attempt to try to give it all equal weight, not to say that, you know, one particular number was more important than how somebody felt about equity and access to a fishery.
Okay, thank you very much. We would have time for one last question, if there is any. Oh yeah.
Hello, my name is Alex Gagne, and I just wanted to pick up on that. I work for 5 First Nations communities on the west coast of Vancouver Island, and we have developed an assessment framework for a gooseneck barnacle fishery that is solely based on melding analytical methods with local ecological knowledge from the First Nations people. And I just wanted to know, how have you weighted these various priorities and indicators through your models? For example, the values that people ascribe to a fishery, how would that be weighted against other considerations?
So short answer is we didn't actually try to weight it. So we deliberately didn't assign any weights. All we did was we did try to identify what were some of the key indicators. So we know what those are for the biology and the economics, but for the social systems, it took a little bit, you know, through the consultation, we came up with a list of what were the key ones, and then we just showed the performance of all of those so that it was transparent. And as I say, it was about making explicit what those trade-offs were, and so different people could look at it and in their minds assign different weight to particular areas which would influence their own personal preference for a choice. But it's sort of similar to what we do in management strategy evaluation, where we usually try and make explicit what the trade-offs are, and the stakeholders then say, well, you know, I like that option because it gives me a really high catch, but there's too much variability from year to year, so they trade those off and they decide I'll go for option C. And in this case, it's the same sort of idea of let's just make those other things explicit, and maybe when they're choosing option C, they'll think, oh, but hold on, that's going to, you know, cause problems in terms of, you know, equity of access to the resource, so maybe option D is a better one. So it just brings in that extra dimension and sort of leaves it to the stakeholders to make value judgments about what's more or less important.
Okay, wonderful. Thank you very much, and thank you very much for the inspiring talk and the very good discussion. Before you clap, we always have presents. Then you can clap, of course. So the ICES book.
Thank you.
To learn more about ICES, and I don't know how many of these books are actually left, but I hope that we have some, and another present. So thank you very much.
Thank you.
Thank you. And yes, she is already approved. She has the button. So this is the end of the plenary. We have a coffee break and then a full-blown set of sessions in the morning. So enjoy.